right? So we have already went through the Hadoop basics and all, but still, right, to get an idea. So um, why are we talking about Hadoop, right? So if you look at here, you have 10 times more data than you did 3 years ago, right? But do you know 10 times more about your business? No, that's a simple answer, right? So the real reason behind the invention of Hadoop is to gain insights from this ever increasing data. So uh, in these days, there was a study which was carried out, and it was found that every year, the total data in the world almost doubles. So it is almost like doubling. So what is happening is that, you are getting more and more and more data, but are you understanding the data more? No, of course, no. That is one reason. And you have a lot of data, like it looks like a puzzle, but you are not able to crunch the data and get the big picture. And that is why we have Hadoop. So big data, when you talk about it, are data sets that grow so large that they become awkward to work with traditional database management tools. Handling big data using traditional approach is costly and rigid. So we have already discussed at this point in the last class, right? So if you're talking about a database, RDBMS platform, they have limitations in handling big data, right? And Google, Yahoo, Facebook, all these companies, LinkedIn, they handle petabytes of data every day. So what do you really mean by petabyte? Petabyte, 1 petabyte is 1,000 terabyte. So every day, these companies are dealing with petabytes of data. They all use Hadoop to solve their big data problem. So that is why we have Hadoop, right? Uh, how and you can see that how big is big data, right? So this is just a slide which I put to give you an idea about the data we are talking about it. So you see we have kilobyte, megabyte, gigabyte, terabyte. Then you have something called petabyte. So usually anything in this area is big data. It can be petabyte, 1,000 petabyte is exabyte, zettabyte, yottabyte, so just to give an idea about the size of the data, right? So anything in this area starting from petabyte to more than that is actually considered big data, right? So Mr. Hadoop says he has a solution to our big data problem. And that is what we discussed in the last class, right? So Hadoop is this platform where you can store big data and analyze big data. So Hadoop is an open source platform for reliable and scalable distributed computing. And Hadoop provides a comprehensive solution to handle big data. So when you look at Hadoop, Hadoop has a component called HDFS. We talked about it, the Hadoop distributed file system. This is where you store your data. In the last part of last class, I also told you that the default execution engine on top of Hadoop is Mapreduce. Okay, so Mapreduce is the default execution engine we have. And if you remember, we also went through this example of Mapreduce program. No? There is mapper, reducer. We picked up a word count program and all. So ever since Hadoop was invented, now I'm talking about 2005 and all, the default processing engine was chosen to be Mapreduce. So in Mapreduce, typically what we do is that you have to use a programming language to write Mapreduce program. And typically, people prefer something called Java. So Mapreduce programs are usually written in Java. This means if I want to analyze big data, the so-called big data, then first of all, I have to be a Java expert. I also have to be a Mapreduce expert. Then only I will be able to do. So some of the timeline for Hadoop in 2008, Yahoo launched their own version of Hadoop. And in 2009, the source code was made open. 2010, Facebook claimed that they have the largest Hadoop cluster in the world with 21 petabyte of storage. And in 2011, Facebook told that the total data is 30 petabyte now. And then it continued. I mean, first few years, I just wanted to show. If you look at an example of something like Facebook, Facebook started in 2004 with 1 million users, and in 2008 they crossed 100 million users, and now they have. So these statistics are a little bit older. So it says now Facebook has 750 million active users. That is incorrect. Okay, so now I think they have almost double the users. What you mentioned, it's not 750 million, almost double that of that, right? So, what is the big data challenge at Facebook? Using historical data is a very big part of improving user experience on Facebook. So storing and processing all these bytes is of immense important. Facebook tried Hadoop for this. So Facebook analyzes all the user activity for a lot of things. So if you carefully observe Facebook, you know that your news feed is very much customized. See, if you log on to your Facebook and I log on to my Facebook, we see different news all the time, right? See, the friends will be different, I know that, but the kind of content that we see changes from users to users. Probably I'm more interested in cars, so Facebook will show me more content related to cars. Maybe you are more interested in motorcycles, you will see motorcycle related content. So the content changes a lot, right? Depending on the individual user. So Facebook has to analyze petabytes of data to improve their user experience. And this is just one example that I have given to you. There are millions of other examples from Facebook. For example, targeted ads. So the major revenue of Facebook actually comes from the ads, right? And each user might see a different ad depending on his taste. So how do you do this? Again, you have to analyze this huge amount of data. So Facebook is definitely using Hadoop for this. So it says Hadoop turned out to be a great solution, but there was one little problem. Yeah, so like everybody predicted, Hadoop turned out to be like a great solution for most of this, right? But there was one little problem. What is the problem? Mapreduce requires skilled Java programmers to write standard Mapreduce programs. Developers are more fluent in querying data using SQL. See, if I have to write a Mapreduce program, then I have to be a Java developer. I have to know in and out of Java or any other programming language. Now, in the big data industry, you cannot say that everybody is coming from a hardcore programming background. So using MapReduce is not everyone's cup of tea. That was the problem. More than MapReduce, people prefer languages like SQL. That is where this tool called Pig comes into picture. So Pig says, no problemo. So what is Pig, right? So let us say that you want to write a program. So basically, I will give you a scenario. So let's say you have a scenario. So you are working for a company and you're collecting all the user data who is, visiting your website. For example, let us assume you are working for Flipkart and you are collecting all the user profiles, how many times they are visiting your website, what page they are clicking, etc. And the business problem is you want to find the top 5 most visited pages by users between age 18 and 25. So I want to know the top 5 most visited page in my website by users in the age group 18 and 25. So you created sort of like a flow chart to develop your logic. And if you write the same problem in MapReduce, this is the code. This is the actual code. Now, I don't really want to show you the code because you will go crazy. So this is actually written in Java. And for a simple analysis, like you are finding the top 5 most visited web page, you're probably writing hundreds of lines of code in Java. So this is the problem with MapReduce. MapReduce is a really powerful execution engine, but if somebody want to write MapReduce program, first of all, they have to be an expert in programming language. And even if you are an expert, even for a simple solution, you have to write hundreds of lines of code. This is not going to work for everybody. Yeah, some people may like it, but this is not going to work for everybody. And this is the same program written in the language of Pig. So what exactly is Pig? Pig is, how do I say, a utility with a particular language called Pig Latin. So basically what Pig does is that it allows you to write your logic in a language called Pig Latin. Pig has its own language that's called Pig Latin. Okay, and the same MapReduce program you saw here, if you're writing it in Pig, you just have 9 lines of data. That's it. So hundreds of lines of code in MapReduce is equal to 9 lines of code in Pig. Now we will get into the syntax and what is a program, those things later, don't worry about it. But as you can see, Pig is more or less like a scripting language, right? So you can understand it a little bit. So here you are loading a data set called users. There are 2 columns, name and age. Then you are filtering the data where the age is between 18 and 25. Then you are loading another data set called pages. Then you are writing a join operation between them. Then you are grouping the data. Then you are sorting the data, taking the top 5 and storing the data. So Pig program will look like this. First point. Now, is that the only thing that you want to learn about Pig? No. So what exactly is Pig? Pig is a data flow language. The language is actually called Pig Latin. So Pig is a utility which supports a language called Pig Latin. And what is the advantage of using this utility? It has a pretty simple syntax. So you don't have to learn Java or any complex language. You learn this language called Pig Latin. You can write your program using Pig Latin. It will run and analyze the data on top of Hadoop. However, there is one more interesting thing. Under the covers, Pig Latin scripts are turned into MapReduce jobs and executed on the cluster. So Pig is kind of like a translator. So I can say that Pig is kind of like a translator. What it does is that you can write a program using this language called Pig Latin. You write it whatever program you want. Then when you want to execute the program, what is going to happen? Pig will convert your logic into a MapReduce program. So end of the day, it will run a MapReduce program. So rather than you sitting and writing a MapReduce program, Pig will write it for you. That's it. So then why people prefer Pig? Because it is very easy to learn this language of Pig Latin. So rather than learning Java, then learning Mapreduce and writing your complex logic, you learn this language called Pig, write whatever logic you want, say run the program, Pig will take your code, convert it into Mapreduce and run it in the cluster. That is exactly Pig. Now, the best way to understand Pig is probably by practically looking at it rather than talking from the theory. So the theory side, we have many things actually in Pig, but our idea is to understand the basics of Pig, right? So we are here just to learn the basics of Pig. So what I will do, I will cover some very basic concepts in Pig, and then we will take a case study, and then we will do the case study and understand more about Pig. Okay, so what I'm going to do, I'm gonna connect with our lab. So we definitely need the lab, right? So I'm gonna use the CloudX lab, and let me just quickly log on to the lab. Okay, I think I have logged in. And I just need to make sure whether the data set is available for me to analyze it. So I'm just going to Hadoop and checking whether we have the data set. So let me just go to HDFS. There is a data folder. Where is it? Yeah. I don't think I have the data set here. So we have to probably upload the data. No worries, I have the data, I will just upload it. So I will just go here, I will say, I have, where is Pig? Okay, here is Pig. Yeah, so I need a Word file. I will share these things with you guys, don't worry. Then I need these dataset students and students new.txt probably. Then I also need this guy. I will just upload it into Hadoop. So I'm just going to upload some data set into Hadoop so that we can analyze it using Pig and get some basic idea, right? The first data set which I want to talk about is a file called students.txt. So if I open this file, so this is just to give you an idea about the basics of Pig, okay? So if I open this file, you can see that this is basically a text file, and it has like 3 columns of data, okay? So the first column you can consider like a student name, then there is the student age, then there is the student mark, or the percentage, CGPA you call it, right? So John is the student name, 21 is the age, and this is the mark. And one thing that is very interesting is that the delimiter here is actually tab. The file is delimited using tab. Now, by default, when you want to read any file and process it using Pig, Pig will expect the file to be tab delimited. So what if I want to process other files like comma separated or space separated? You can do that. So I will show you how to do that. But my point is, by default, what Pig will expect is that the files that you're having is tab delimited. So this file is actually having tab as the delimiter. And what I can do is I can connect with our lab. So I'm going to open the web console. And I will just demonstrate something and then get back to your questions, okay? In case if you have any questions, we will pick up the question, no worries. But first, I will just quickly demonstrate Pig and then we will look at it. Now, how do you work with Pig? So there are 2 ways to work with Pig, Okay, so if I want to write a pig program, right? There are two ways to work with pig. One way is that pig has an interactive shell. So there is something called pig shell. You can just type pig, hit enter, and the moment you type pig and hit enter, you can see that it will give you a shell. So this shell is called grunt shell. So one way to work with pig is that you can type your pig commands one by one in the grunt shell. So the first command that I'm going to show you is how to load the data. Okay, so anyway, you want to analyze the data, right? So the first step will be that you should learn how to load the data into pig, right? So to demonstrate that, if I go to Hadoop, like I said, we have this file called students.txt. This is the file we want to load. So I can just say a equal to load, okay? And let us see what will happen if I just say students.txt. So what did I type? I typed a equal to load students.txt. I did not mention anything. I just mentioned that I want to load the data and this is my file name. Now, honestly speaking, do you think this will work? No, it will not work. Because you see, this students.txt, it is located in a particular directory, right? If you go to my Hadoop, this is inside user Raghuraman AV3825 then data. So this is basically the location of my file. But in my command, I'm just saying, hey, load the file. But if you carefully observe, you are not getting any error. So A is kind of like a variable. You are saying that load this data to A, and you are not getting any error. That is because by default, Pig follows something called lazy evaluation. There is a concept called lazy evaluation. Whenever you try to load the data or analyze the data, Pig is not actually running anything behind the scene. So if you're thinking that, is Pig actually trying to load the data right now? No, it is not trying to do. By default, what Pig does when you write a statement like this, it will just remember the statement. That's all. It is not going to execute the statement. That is why you did not get an error. Now, if you want Pig to execute this statement, you have to say dump A. So the second command I'm going to introduce is called dump. What do you mean by dump? Dump is a command which will basically show you the output. So I'm telling Pig that, hey Pig, show me whatever is in A. So you said in A, I want to load this data, right? Now show me the output of A, that is dump A. If I hit enter right now, Pig will try to analyze the data, I mean load the data, and it'll throw an error. So here you can see, this is where I said dump A. The moment I say dump, it tries to check what is inside A. It tries to load the data, and it clearly gives me an error. Input path does not exist. That is absolutely correct. The input path is incorrect. So how do you load the data? You have to ideally say load, then you have to say the complete path, user, let's say Raghuraman AV3825 /data/students.txt. So now the load command is actually pointing to my file because I'm giving the complete location of my file. It is actually pointing to the file. And now if I say dump A, what I'm trying to do by dump A, I'm asking Pig, hey, show me the output of A. Dump A simply means show me what is that you're storing in A. So if I hit enter, now what will happen? Pig will convert your logic into a Mapreduce job. It will load the data into a variable called A, and then show you the output as well. If we wait for a moment, it will show that. Yes, see, this is the output. So basically, this is the data that we are storing in the students.txt, right? And if you carefully observe, each row of your data is converted into something called a tuple. There is something called tuple or tuple. Okay, so some people call it as tuple or tuple. So what is a tuple? A tuple is nothing but group of data. So the way Pig reads your data is that each line of your data from the text file, it is going to convert to a data type called tuple and then stores it. So you can see that each row of your data is kind of like loaded like that. Now in Pig, you can also apply schema because it might be important, right? So for example, John is something like a string value, 21 may be integer, this may be decimal. So in Pig, you can also attach the schema. Right now, we did not do that because right now what we did is that we just said load the data. If you want to see the schema of a variable, or we call it as a relation in Pig, you can just say describe A. So when I say describe A, Pig says schema for A unknown. And you cannot blame Pig because you are just telling Pig that read the data. You are not mentioning any column names or data types or anything like that. So when you are loading the data without any proper column names or data types, and if you run a describe command, Pig will tell you that, hey, I don't understand what is the schema. So how do you load the data with proper schema? You can reload the data. You can say load the data as, then you can say name, that is first column name, age, that is a second column name, and GPA. So now look at my load statement. I'm saying that I want to load the data, but the data will have name, age, and GPA as kind of like column names. We cannot call them column names, but we can say they are the headers kind of information. And now if I say describe A, what will happen? You can see that now A has name, age, and GPA. And if you look at the data type of each column in your data, you can see that it is byte array. Why it is byte array? Because that is the default data type that we have. So what happens is that since you are not mentioning whether it is an integer or a string or a decimal or a float, Pig is using the default data type that is byte array. Now, if you want to load with the proper schema, even the data types, you can say name is char array. So there is no string in Pig, we have char array. Age is integer, GPA, let's say float. And now you can see the load statement has the proper schema, name, age, GPA. And now if I say describe A, you can see that A has this variable has a proper structure. And I can say dump A just to see the output of A. So let's just check. Yes, so the output still remains the same. There is no difference. However, now the relation called A actually has a proper schema. So when I say describe A, you can see that A has this. Now, one thing you need to understand about Pig is that Pig does not store your data like a table. So many of you might be coming from the RDBMS background, and you might be familiar with rows and columns. But in case of Pig, there is no concept like rows and columns. To give you an idea, what is going to happen, let's say somewhere you will have it. Yeah. So when you create this relation called A, Pig is loading every row of your data as a tuple, right? Every data is getting loaded as a tuple. So, and when you attach the schema, I don't know whether we have that somewhere. Let me just check if you give me a moment. Somewhere I had created a notepad to explain this. So have a look at this data. So let's say you have a CSV file like this, where you have the state name, then you have the year, then you have a column called professional profile, then you have whether unemployed or housewife, then you have male, female. So if I'm loading this file into A, let's say I'm loading this file with, you say, state, char array, year, integer, profession, A is what you call a relation. The data type of A is what you call a bag, and this basically contains tuples. So the schema that you're mentioning is attached to every row of your data. It is not like your RDBMS. In RDBMS, what happens, you will divide your data into columns. There will be column name and data type. In case of Pig, there is nothing called a column. There is nothing called what you say, column header. The schema that you're mentioning gets attached to each row of your data. That is how Pig is looking at your data. Okay, so what did we learn? We loaded the data. Now we know how to load the data. Now, I will be sharing this Word file with you. So I have created a Word file called Pig. This will give you a lot of information about Pig. Also, this has a couple of tutorials like how do you load the data. So this is what we have been doing. We were actually loading the data, like you see. The students.txt file we have loaded. This is exactly what we have done. It is just an explanation of what I have doing. Now, how do you transform the data? Transforming the data. Yeah, loading the data is one thing, but what I really want to do is transform my data. Meaning, I want to analyze the data. So if you want to analyze the data in Pig, right? Pig has a lot of built-in operators. We call them operators. What is an operator? Operator is nothing but a built-in function in Pig, which will help you to analyze the data. So let's suppose you have loaded this data into a relation called A. Now, I will introduce a couple of basic operators for you. For example, there is an operator which is called filter operator. So have a look at here. So let's say you want to filter the data. You can use this filter operator. How do you use the filter operator? You can say something like this. So A is your original relation. And now I can say I want to create one more relation called R, where I want to filter A by each column more than 20. So filter operator allows you to filter the data. And how do you use the filter operator? You can say, I want to filter the relation A by a column called age, and the condition is I want all the data points where the age is greater than 20. So in Pig, whenever you are writing a program, you write it like a flow chart. So the first relation will be A. If you modify A, you store it as some other thing called R. Or maybe if you modify R, you store it as some other thing. So you write it more or less like a flow chart, I can say. Okay. Now, if you want to see the output, let's say I want to see all the students whose age is more than 20, I can say dump of R. So R will contain all the filtered data. I can say dump of R, and it will fire a MapReduce job. It will convert your logic into MapReduce, fire a MapReduce job, and here is the output. So like we expected, there are total 5 students, but only 3 students are more than 20 of age. So we can see that. Now the filter condition can be even applied to multiple columns. For example, I can also say like this. I can say I want to filter a by where age is greater than 20 and GPA greater than 3.5. So when you apply the filter, either you can give a single column for filter, or you can give multiple columns as well. So in this example, I'm saying that, hey, there are two columns, age and GPA, and I want to look at all the students whose age is more than 20 and their mark is more than 3.5. And if I say dump R, so it fires a MapReduce job. As you can see, there are only two students which matches both the condition. So filter is a built-in operator which we can use to filter the data. Okay, the next operator is called for each operator. So for each operator is like the select operator in SQL. For example, in SQL, you will say select star from table, right? A very common query in SQL will be select star from the table. The same thing if you want to do in Pig, you can say R equal to for each A generate star. So for each generate, they come together. So this is equal to writing select star from A. So this means I want to select all the data from A. Star basically means all. So you are saying that for each A, I want to generate star. For every row in A, I want to generate star means all the columns. And now if I say dump of R, R will have same data like A because it is more or less like select star. So when I check the output of R is having same thing like A. But you can also say R equal to for each A generate, let's say name. So this is equal to writing select name from the table A. So let's say you want to project only one column. What you will do? You will say select name from the table. So very similar to that, you can say for each A generate name. Now if I say dump of R, let's see, you can see that you have only the name column. There is only the name column. So for each generate is actually used to, how do I say, it's actually used to select whichever columns or whichever part of data you want from the original relation. That is the for each idea. Okay. Now after this, what you can do, so that was the next step operator. I will also introduce one more operator that is called the grouping operator. So if you want to group the data, you can do something like this. So let's say I want to group the data. I can say group the relation A by age. So age is the column. So this is like group by age in the SQL query. So in the SQL query, you will be saying group by some column. So very similar to that, there is a grouping operator in Pig. I can say group A by age. But what is interesting is the output of grouping. So when I say dump of B, I want to see the output of group. This is how the grouping output will look like. Now I will tell you why it looks like this, because what you did was Yeah. So what we did was that we said group A by age. This is what we wrote. And the output is this. So when you group the data, the output will be like this. The output will have two parts, basically. I'll just write it so that you can understand. The output will have a grouping key. For example, you're grouping based on age. So the age will be the grouping key. Then this will be matching tuples from A. So for example, 19 is the grouping key. So you said group by age. 19 is one value for age. Then that will be the grouping key. Then Pig will give you the matching tuples from the previous relation A. So you can see Sally and Doug are here. Okay. Again, for 21, there is one tuple matching. So whichever tuple that is matching will be given to you like this. Okay, so that is how you look at the grouping output in this case. So there was one question, is it a .tsv file that you are speaking about? It's not a .tsv file, it is a normal text file, but it is a tab separated file. So you can consider it like a TSV file. I stored it as a .txt extension, but it is a tab delimited file. Prasad is saying how null values for a column is handled. So in order to handle null values, there is a function called isNull. And there is one more function called isNotNull. Not null. So you can say isNull and isNotNull to check null values in a column. So these two built-in operators are there to track the null values we have, right? Tushar is saying, does Pig work in same way as Google BigQuery? No, Google BigQuery actually uses SQL. Pig is not using SQL. Pig is using its own language that is called Pig Latin. So if Pig was using SQL, then I don't have to teach you that, right? Because most of you know what is SQL. Pig comes with its own language called Pig Latin. Now, I should also tell you that the importance of Pig in the industry, people actually use two separate tools. There is something called Pig and there is something called Hive. So there are two tools in the industry. One is Apache Pig, which we are learning. Second is Apache Hive. We will learn Apache Hive tomorrow. Basically, Apache Hive is a SQL platform on Hadoop. So Hive will allow you to write SQL queries on big data. Pig allows you to write Pig Latin language queries. Prasanna says, which storage database Pig support? No, Pig does not support any database, Prasanna. Pig supports only Hadoop. So your data has to be on Hadoop, HDFS. So the data should be on Hadoop or HDFS, then Pig will be able to read and process it. But also understand that Pig is not the processing engine, because whatever logic you are writing in Pig, it is converting that logic into a series of Mapreduce programs. Okay, so that is basically what is happening with Pig. Great. So we looked at some very basic things in Pig. We looked at the filter operator, group by operator, how to load the data, etc., from the Pig, right? Any other questions in Pig? Let me know. Can we use Pig for data validation? Yes. The actual use case of Pig is data cleaning, actually. You can say data validation, but more than data validation, Pig is used for data cleaning, right? What do you mean by data cleaning? Let's say you are getting a log file and you want to, so if you look at a log file, right, the log file will have a lot of unwanted characters, special characters, extra information. So if you want to clean them and convert them into a proper structured format, you can use Pig. Now, in this example, I'm showing you a CSV file and structured data, but Pig can also work on unstructured text data. So it can be used for data validation, data mining, and cleaning of data. All these things it can be used. And Pig was created by this company called Yahoo. Yahoo was the company who created Pig. Okay. Now, let us do one more simple case study so that you can understand the way you work with Pig, right? I will complete this case study and then get back to your questions. So in this case study, we are talking about some movie data. So let me upload the file because I don't think it is available. Just copy this file. Yeah. So I have a CSV file called movies_data.csv. Let me show you the file. So this file basically has around 50,000 records. It's a very big file. And the way you read this file is that, okay, I think the way you read this file is, this is actually talking about some of the movies. So there is a movie ID here. Then there is a name of the movie. So if you look at here, there is something called Nightmare Before Christmas, The Mummy, Night Tide, Mother Boy. So many movies are there. So there is a movie ID, movie name. Then there is the year of release, when the movie was released. Then there is this rating for the movie out of 5, 3-star, 4-star, 5-star. Then there is the duration of the movie in seconds. So the last column is the duration of the movie in seconds. How many seconds? So if you convert it into minutes, you can actually get it. Now, my challenge here is that I have a CSV file. So this is like comma separated file. So how do I load it into Pig? So it's actually very easy. Let me show you how this data can be loaded. I just need to change the only one thing, the location of the data. Load, let's say, So in order to load the data, this is how you will be able to load the data. So what is the difference here? I am saying load, and this is definitely the location where my data is. You can say using Pig storage, comma. So here you can say, so when you say using Pig storage, comma, Pig will understand that your delimiter is comma. If you have semicolon as delimiter, you can say using Pig storage, semicolon, or whatever it is. Then the remaining thing is same. You are saying that there is an ID column which is integer, name char array, year integer, rating double, duration integer. Now let's verify whether we are able to actually load the data. So if I say dump movies, I should see the output. Yes, as you can see, it clearly prints the output, so each movie is like a tuple, and there are many movies, also series. The data actually contains movies and series, so many of them are there. I don't know, say so many Alfred Hitchcock, so many movies are there. So we are able to load the data successfully. Now, what is that we want to do with the movie data? So let us say we want to find out the longest movies from the data. So here, if you look at it, this is what I want to analyze. What were the longest movies? So let's say you want to find out the top 10 longest movie from this data, right? So how do I actually do it? Because there is a duration column, and the logic will suggest that, okay, I will first look at the movie data. So I will write the steps, then it will be easy for me. So I want to find out the top 10 longest movies, right? This is what I want to do. How do you do this? So step number 1 is load the data. We have already done that. Step number 2 is that extract the name and duration column, because we are interested only in the name of the movie and the duration. Third step will be, let's say, convert the duration into minutes, because you want to look at the duration in minutes, not by seconds. Fourth step will be find out whether there are any null values in duration. If so, remove them. Okay. Step number 5 will be sort the data in descending order based on duration. Okay. Step number 6, from last step, take the top 10. So whenever you are creating a pig program, you actually first write the steps like this. This is the way we follow actually in the industry. So if I want to find out like the top 10 longest movies, I won't just say, okay, let me try to write a program. What I do is that I write the steps. So first step will be that I load the data. Then I say that I will pick up only the name and duration column. I convert the duration to minutes. And if there are null values, I get rid of them. Then I will sort the data in descending order, limit the data to 10. So top 10 longest movies will be there. So we will do this using Pig, but we will take a break. So I will write here, we are on break. So it's almost an hour. Let's take a quick break, and I will say we'll resume at 8:10. Thank you. So let's take a break and rejoin. Thank you. Welcome back, everyone. So let me look at the questions window. Okay, give me a moment. I'll just have a look at the questions window. There is a question, by the way. Where is the questions window? Okay, great. Okay, could you please repeat this once again? Oh, I missed it. Which part you were asking, Shravya, to repeat? Which one were you asking to repeat? I missed it. I'm sorry. Or maybe what I will do, I will just show you this. If you were asking about these 6 steps, I will practically show you this, so it will be easy for you to understand. Right? Yeah. So rather than, so we want to find out the top 10 longest movies, right? And these are the steps we are going to do. And already we have loaded the data. If you look at here, the data is already loaded. So there is a relation called movies, and we have already loaded the data. So movies, the data is actually loaded. The second step that I am going to do is that I'm going to select only the name column and the duration column. So I'm going to say for each movies, generate name. So from the movies relation, I want to pick up the name column, and I also want the duration column divided by 60. Why? Because the duration column is in seconds. So you are just converting this into minutes. So if you look at this relation called movie duration, let's say, let's do a describe on this, okay? Describe movie duration. So when you look at this relation, you can see there are 2 columns. First column is name. Second column, we do not have a name because I just said divide the duration by 60 and create a column. I did not give any column name. So if you want to access this duration part, you can use a positional notation. If you want to access the name column, you can say $0. If you want to access the duration column, you can say $1. So Pig allows you to access the positions using this dollar notation. So either you can say name or $0. The second column, there is no name. So I'm going to call it as $1. So we loaded the data. We selected only the name column and then the, what you say, duration column. And now what I'm going to do, I'm going to filter the data, okay, for null values. So I'm going to say that I want to filter the duration variable or the relation by $1 is not null. So somebody asked today, how do you handle null values? This is how you handle null values. So here I'm saying that I want to filter the data, and what is my condition? I want to see all those rows where the duration is not null. So you can say is null or is not null. So I'm saying is not null, and this will create a new relation called movie duration not null. Once you get it, what you do is that you can sort the data. So I can say order the relation by $1 descending. So order is the operator for sorting the data, and this is the data that you want to sort. And then you're saying that sort the data by the second column in descending order, you can say, right? So here you're saying that you want to sort the data by descending order. And to get the top 10 what you can do is that you can use the limit operator. Hey, why Alt tab is not working? So what we did, if I have to explain the steps, in this step, you loaded the data. I think all of you understand this because I'm just saying that load the data gets loaded. In this step, okay, you are saying that from the data, give me only the name column and the duration column. Okay, and also you are saying that the duration column should be divided by 60 because it is in seconds you want to convert to minutes. So the output will have two columns. First column will be name. Second column, there will be no header, no title, because it is a derived column. You are just dividing this duration by 60 to produce a new column. So in order to access our new duration column, I will be using $1 as the operator. So once I get this, okay, the next step is that I will filter the data where I will say filter by the duration column is not null. Okay, so basically you're saying that look at all those records where the duration is not null. Then you will say order the output. Order means sort by the duration column in descending. Then finally you say limit 10. So this is like in SQL you say select star limit 10. So now if I say dump longest movies, I should get the final answer. Let's see. So this is now firing MapReduce job. Let's just wait for the output. So it is firing a MapReduce job, as you can see. And this might take a minute because you are doing a lot of sort, order, everything. And yes, here is your output. So these are the top 10 movies or series based on duration. Okay, as you can see, they are the top 10 movies. Now I will be sharing this data set and the steps with you. You can also try this by yourself to get an idea as to how we were doing. But just to reiterate what we were doing. So what we did, we selected the name column and the duration column. Then I filtered the data by duration is not null. Then I sorted the data based on duration in descending order. Then I said limit 10. So this is like SQL, select star from the table limit 10. Finally, I did a dump and I was able to get the final output. Okay, so this case study, I would like to wind up now, right? So what is going to happen now is that I'm going to pick up one more case study because in your syllabus, if you look at it, there is a case study on IPL data. So all of us are aware of IPL, right? Indian Premier League. So I have a file which basically has the IPL match data. So let me open this file. Yes. So it is an Excel file. The file is an Excel file. And the first 19 lines of this is actually metadata. Meaning, whenever you collect cricket score from any actual match, the data will look like this. So the first 19 lines are the metadata. Metadata means here you can see what are the teams. So first team is Gujarat Lions. Second team is what? Sunrisers Hyderabad. What is the gender? Male. When was the season? 2016. When was the date? And what is the competition? IPL. What is the venue? Firozshah Kotla, Delhi. So who won the toss? So all this information is there in the first 19 lines of data. Okay, after this, you have the actual match data. So this is the actual match data. Okay, and how do you read this data? So let me take one line and then show you. Maybe I will zoom in a bit. So if you look at this line, right, let me highlight it. How do you read it? So it starts with a ball. So every delivery is counted as a ball. Then you can see the over 104. So first over, fourth ball. Gujarat Lions is the team batting. Dwivedi is the batsman at striker's end. McCollum is at non-striker's end. B. Kumar is the bowler. It was a boundary, that is 4, 0 runs extra. Now, if you read this line, let's take this line, okay? This line again, if you see, it is the 7th ball, same things, Dwivedi, McCollum, B. Kumar, 0 run, 0 extra, it's caught. So the batsman is out, and the batsman who went out is Dwivedi. So the structure of this file is actually given in this PDF. So here there is a PDF. So here I have given the structure of the data. So you can see that it contains 12 columns made up of the following. There is ball, team batting, overs, batting team, batsman. So if you go through this, you will understand it. Now what we are supposed to do, we are supposed to load this data and do some basic analysis using Apache Pig. Okay, so the data is already there. I just want to load it. So I will just copy the command from here. Control C, Control V. Okay, I think I need to change it because the location is different. I want to copy this. The problem is the location is different. Also, it is an Excel file. And where is my data? It is in a folder called data. Right. Now let's load the data. So here you can see I'm running the pig command. I'm saying load the data using pig storage comma, because I know that in my data everything is separated by comma, and this is my schema. This whole thing is my schema. Now let's verify. So the relation name is actually IPL. Let's verify whether this is working. I can say dump IPL. Let's see whether we are getting some output. Okay. Yes. So as you can see, Pig is able to read the data. Each row of the Excel file is converted into a tuple. We can see it is printing the output. So we are able to basically load the data. Now let's try to answer some questions. For example, one of the first question we have is, how many runs did David Warner score in the match? Okay, how many runs did David Warner score in the match? Now, this is slightly a tricky problem. Okay, so this is slightly a tricky problem. Now, why do I say it is a tricky problem is because normally in an RDBMS table, you can always do column level aggregations. You can say count star, or you can say select one column and then do a sum of that column, max of that column. So whenever you are writing normal SQL queries, you can do column level aggregations. In case of Pig, this is not possible. Because in Pig, there is nothing called a column. So let me show you a simple example for this. Where is the example? Give me one moment, okay? No, this example may not work the way. Let me show you the example by running the command. That will be better. So what I want to do is I want to find how many runs did David Warner score in the match. So David Warner is the batsman, right? So I want to count how many runs, or I want to sum how many runs he has scored. So first thing I want to do is that I'm going to filter the data for David Warner, because you don't want the data for everybody. So I'm going to say that filter the relation by batsman 1. So what is batsman 1? That is whoever is on striker's end. Batsman 1 matches DA. So what is this matches? You are basically using something called a regular expression. There is something called a regular expression. So regular expressions allow you to do pattern matching. So David Warner, if you look at the jersey, if you look at his actual name in the uh, statistics, it will be written D.A. Warner. So I'm saying that filter the data where I want to look at all those records where the batsman on striker's end start with the name DA. Now let's check what is happening here. If I say dump filter David, if I just wait for this to check, let us see whether the filter is working. Yes, now the filter is working. So if you look at my output, you can see all the records where there is David Warner. But now my problem is I want to count how many runs he has scored. So basically I want to add this 1 plus 1 plus 6 plus 1 plus 4. I mean all the runs he has scored. If this was a SQL table, you will say select count of the column or sum of the column. You can easily do that. But unfortunately, in Pig, you cannot just say, hey, count runs. It will not work. You cannot vertically operate in Pig. So I'm going to use a shortcut. What I'm going to do, I'm going to create one more relation. Let's say A equal to, I'm going to say group filter David. Let's say by DA Warner. So what am I trying to do? I'm going to group the output by DA Warner. So you may be wondering, what is this? Because each line has David Warner. We just filtered the data only for DA Warner. Then why are you grouping with DA Warner? This is a trick actually I'm doing. So after the grouping, if you look at the output of A, if I check A, let's see how the output looks like. You can see that when you look at the output of grouping, David Warner will be the key. The value will be all the tuples which contains David Warner and his runs. And now what I can do, once I get the data like this, what I can do is that I can say, let's say runs by David equal to, I can say for each A, generate, I will say sum of filter David dot runs. And now, so what I'm doing here basically is that from the output, okay, I'm just generating sum of, runs from this. Now, if I say dump of runs by David, you should see the final output. Let's check. If you did not get the logic for this, don't worry, because in the next question, I will explain the logic again, because in the next question also, I'm going to use the same logic. So the output is 93. So total David Warner has scored 93 runs. Okay, great. Let's check this third question. This will give you an idea about same thing, right? So the question is, how many wickets did DJ Bravo take in the match? Right. So what I'm going to do here is that, first of all, I want to filter the data by DJ Bravo. What is it? Oh, I think run out. Yeah. So first thing I'm going to do, I'm going to create a relation called Wickets by Bravo. I'm going to say I want to filter the data where the bowler is DJ Bravo and result not equal to run out. So I want to count how many wickets DJ Bravo took. That is my idea. So the first step that I'm going to do is that I'm just saying that, hey, filter the data where the bowler is DJ Bravo and the result is not equal to run out. So there is a result column where you have like catch, LBW, etc., etc. Now you know that when there is a run out, the bowler will not get the wicket. So I'm using this AND condition and saying that, hey, the bowler has to be this guy, but you know it should not be a run out. And now I can say A equal to. So let's look at this wickets by Bravo. So I'm going to say wickets by Bravo. If I check this, yes. So there are only 2 wickets DJ Bravo got. There are only 2 wickets. You can see only 2 tuples are matching with this. Now, you may be wondering, why don't you just count it, right? Why can't you just say count star or just count it? See, it's actually impossible. You cannot do that. Okay, so because Pig does not support column level operations, I cannot say count star or count the number of balls. None of this I can do. So instead of this, what I can do is that directly I cannot count, but what I can do is I can use a small trick here. So let me give me a moment. Give me a moment. Hey. Yeah, so what I'm going to use here is that I'm going to say A equal to group, let's say wickets by Bravo by, let's say, what is his name? DJ Bravo, right? DJ Bravo. So I'm going to say I want to group the data by DJ Bravo. So if you do that, if you check the output of A, what will happen? The grouping will basically bring all the tuples in a single row, so you can count. So let's check the grouping output. Yeah, so you can see that DJ Bravo is the grouping key. Then you have all the matching tuples from the previous relation. So now what I can do, I can say the final output B will be for each, let's say A, generate, I want to do a count of, let's say, what is it? Wickets by Bravo. What is it? Why it is wickets by Bravo? What is the spelling mistake? Wickets by Bravo. Spelling mistake? Projected field wickets by Bravo. Oh, I have to write it as a single line. So I can just write it as a single line as well, like this. Can just say that this. Finally, if I say dump of Bravo Wickets count, I should see the output. Let's wait. So see, the idea is not to teach the entire pig to you. Okay, so if some of you are wondering that, hey, what's happening? So the output is 2. The idea is not to make you like experts in pig or something. The idea is to tell you that there is something called pig. It has a language called pig Latin. Pig Latin has some built-in operators like group by, filter, and all. And you can write your logic using pig Latin and run it like this so that you can analyze the data really easy. So this is basically the idea. Now, if you want to go in depth, you have to sit for probably a couple of hours to learn how this is working, but that's not the intention behind the session. We are just introducing pig, right? What is this? Now, in production, what we do, once we are able to figure out how to create a pig program, you can run it as a script. Let me show you. So what I can do, I think there is some problem with the lab. Let me reconnect again, okay? So I'm going to take the web console once more. So in production, what you can do when you want to run a pig job, you don't have to open the shell and then type one by one. That is not possible as well, right? So let's say you're working for a company and somebody asked you to do this analysis. Every time you cannot open the shell, type one command, type the second command, type the third command. No. So initially, when you're developing your logic, you will do so like that. But later, when you have developed your logic, you can create something called a pig script and keep all your data in that. So let me show you how to create a pig script. Okay, so I'm going to create a new file called ipl.pig. In this file, I'm going to give my commands that I want to use. For example, this is the first command. So here I will write, okay, load the data. Then I will say that, let's say you are counting this wickets by Bravo. Then you will say, I don't know whether this will work. Yeah, count of wickets by Bravo. Then you can say dump Bravo wickets count. So this way you can actually write something called a pig script. Pig script basically means you are keeping all the commands that you want to run in a text file like this. Now I can just save it and it is called ipl.pig. I can just say pig, run this ipl.pig, hit enter, it will run it for me. Let's see whether there is any error comes up. I think it is running. So it is now running the script for me one by one. It is analyzing. Yes, so the final output is here 2. See, the output is 2. It printed the output. So this is the way we actually run in production. You will be creating a script and then you will be running the script. You don't open the shell and type it one by one. That you don't do. Let me also do one more thing. Let me create a Google Drive link and share the material with you, right? So that you can get it right away. So I will say, let's create a link called Board Infinity. And And inside this, let's copy this PDF. This was the PDF I was running. Then I also want to share this IPL case study. There is the IPL data, there is the movie data, this one, and this one. So these data sets I'm putting in the Google Drive. And let me also share the Google Drive link with you. Share, copy link, and yeah, let me put it in the chat window. Yes. Can you guys just check whether you are able to access this Google Drive link? I have pasted a Google Drive link in your what you say, chat window. Just check once. I hope you are able to access. Yes, okay. No, it requires permission. No, I made it public actually. Give me 1 moment. I don't think there is any. Oh, restricted change. Sorry. Anyone with the link. Yeah, so I just updated the permission. Okay, just refresh. Okay, after it is done. Yeah. So now can you guys refresh and check once more? I just updated it. Yes, you can. Right? Yes, now it will be working. Okay, so going back to the slides we were running, we already went through a couple of slides actually. And now if you look at this, you will understand, right? So what we were trying to do here, we were trying to find out the top 5 most visited pages. And now if you look at the solution in Pig, you can understand it. You were using the load operator first, then you were filtering it, again loading it, again joining it, grouping it. So all these operators you were actually using it, right? So what is Pig? We have already covered this. And how do you compare Pig versus SQL? So Pig is a procedural language, SQL is declarative language. So that is one difference. And Pig has a nested relational data model. SQL has a flat relational data model. What do you mean by this? In SQL, your data is always related to a particular data type. Pig does not have that constraints actually. And in Pig, schema is optional, meaning even though in our examples today, we were using the schema, Pig can actually work even without the schema. So you don't have to always provide the schema. Even if there is no schema, Pig will be able to work on that. On the other hand, if you look at SQL, you can know that SQL always requires schema. And Pig scan-centric analytics workloads and SQL is OLTP OLAP workloads. Meaning in Pig, what we do is that we scan the whole file, kind of like a data mining kind of like operations. SQL probably is like you are picking up, let's say, a couple of extra lines or extra rows from a table and then analyzing it. So the way you analyze it is actually different. In Pig, you have limited query optimization. SQL, you have very good query optimization. And some of the features of Pig, you can join the data sets. So in SQL, you have this concept of join operations, inner join, outer join, full outer, left outer. All those join operations are also supported in Pig. You can also group the data. We have seen that. Referring to elements by position rather than the name. So in the movie example, we actually used this feature. So I was saying $1. I was referring based on the position. Loading non-delimited data using a custom SERD, right? So this is something which is a bit advanced concept. What do you mean by a custom SERD? A SERD is a serializer, deserializer. So if I have structured data like separated by comma, separated by tab, it's very easy to load in Pig. But sometimes you have data which is not structured. In that case, you use something called a SERD. You can use your own serializer, deserializer to load the data. Creation of user-defined functions written in Java. So what is this UDF or user-defined function? If you think Pig is lacking some functionality, you can create it with the use of something called UDF, user-defined function. So we will see that in the slides. And under the hood, we have already seen that. Yeah, so Pig Latin UDF. Pig provides extensive support for user-defined functions as a way to specify custom processing. Functions can be part of almost every operator in Pig. So what is this concept of UDF or user-defined function? See, let's suppose that you are analyzing the data from, let's say, a bank. So let us say you have collected the data from a bank and then you are analyzing the data, right? Now let us suppose the bank has a column where they are noting all the transactions. And the transactions are in US dollars, okay? So the transactions are actually in US dollars. You want to convert that into Indian rupee. So you can write a function to do that because Pig by default will not know how to convert from dollar to rupee and all. So what you can do, you can write your own function in Java or any other language and use it. That is called UDF. So there are many types of UDF functions. There is a list of them actually. And there are some examples, but these are a bit advanced examples and I'm not going to do that, right? All is well, but what about the performance trade-off? So performance of Pig versus Hadoop Mapreduce. So when you look at the time you take to write a Pig program, it is much, much better than Mapreduce, right? So you can see three pictures here. So first bar chart says 1/20th line of code. See here, this one. This guy, it basically says 1/20th line of code, meaning if you are using 20 lines to express your MapReduce program, it can be done with a single line in Pig. And here you can see 1/16th development time. So even the development time is very less, 1/16. Performance when you run it is also better. Why the performance is better is because if you are writing native MapReduce, you may make mistakes, you may write the program very lazily, right? So it probably takes more time to run. But when Pig is converting your logic into MapReduce, it will ensure that the program runs really fast. So that way, performance-wise, Pig is also better. Okay, so And if you want to learn more about Pig, right, there are some Pig tutorials available. Let me see if I can share it with you. Give me one moment. Uh, just go to Google, search for Hortonworks Pig tutorial. Yes. So there is a tutorial actually. So if you want to learn further and you want some more explanation, you can go to this beginner's guide to Apache Pig. Give me one moment. Okay, I think, yeah. So if you want to learn more about Pig, you can actually go through this particular, tutorial. So here it says what is Pig, detailed explanation. You can download the data, upload the data, so everything is given here. So I will share this tutorial as well. Any questions, let me know. So we will probably wind up, but before I wind up, let me know in case if you guys have any questions, I will answer them. So I have shared the link in the chat window. Have a look. I've shared the link in the chat window. So in case if you have any questions, you can stay back or else you are free, feel free to leave as well, okay? Let me check the questions, okay? Okay, thank you. Thanks a lot. Thank you. And Aditya was, can we use Pig to validate like all record data? Yes, you can do that. That is actually a use case. You can do that. Okay.